All right, here we're going through Activity 11, the Unit 3B Exam Review Part 2. So my first section is just to write the formula from the following pairs of ions. So with these, all I need to do is the crossover method, turning the charge of one into the amount of the other. Since both of these are 1 and 1, my formula is just FRF. Next, I'll do the same thing, turn the charge of potassium into the amount of NO3. So I just get KNO3. Next, one more crossover, I'll have Ba3 AS2 because my charges and amounts swap. Next, a crossover with polyatomics, so I need to be sure to keep anything in parentheses. I'll have 3 NH4s and 1 PO4 because I'm simply swapping the charges. Nothing changes about the PO4 or the NH4. Next, Ca plus 2, WO4 minus 2. That means I have Ca2, WO4 2, which is going to simplify just into CaWO4. Next, Sn plus 4, Cl minus 1. When I cross those over, I'll get SnCl4. Fairly straightforward there. Now we're writing the correct name from each of the following ions, and this should be easy. I just need to name each of the ions and indicate a charge with a transition metal if I need to. So Cs and OH, neither of those are transition metals, so I'll just name them straight up. This is cesium hydroxide. Next, neither transition metals again, so I just name them straight up. This is magnesium sulfite. This SO32 minus is on the back of the periodic table, called sulfite. Next, again, no transition metals, so I'll just name them straight up. We have ammonium sulfide. And lastly, again, no transition metals, so we have aluminum. And then ClO is called hypochlorite. So this is aluminum hypochlorite. Here we move into the section where we're naming things as or writing the formula. I'm going to go ahead and cross out this one because that one was a typo and can't be done. So magnesium thiosulfate is going to be ionic because it has a polyatomic and it has a metal and an anion in it. So magnesium is Mg plus 2. Thiosulfate is S2O3 minus 2. So when I cross those over, my formula becomes MgS2O3 because I simplified the 2's out. Sodium fluoride, another ionic, where I have Na plus 1, F minus 1. So my final answer is just NaF. I do not include this as part of my final answer. Ammonium bromide, another ionic. I have NH4 plus 1 and Br minus 1. So when I cross these over, I get NH4Br. Lastly, in this, or two more in this column, lithium iodate is another ionic, so I'll cross over Li plus 1. Iodate is IO3 minus 1, so when I cross them over, I'll get LiIO3. All those fairly straightforward because most of the charges are equal. In fact, all the charges were equal. Again, the answer that I'm looking for is this part. The part that I'm showing you is just kind of showing my work. Lastly, we have Ci4. This is a covalent compound. Let's see, that was kind of in the wrong place. And so if we're going to name this, we use our prefixes. This is called carbon tetrabromide. All right, moving on to the next section. We have a covalent compound because it's nonmetals and there are prefixes. Trichlorine means Cl3. Hex oxide means O6. We do not simplify covalent compounds because the amounts are based on the prefixes. Another covalent compound, disilicon, tells us we have Si2. Tetrasulfide tells us we have S4. Next, we have copper 1 nitrite. This is an ionic, so we'll do the crossover method. Cu plus 1. Nitrite is NO2 minus 1. So when we cross over, we get CuNO2 as our final answer. NaBr is ionic. There are no transition metals, so I don't need Roman numerals, so I'm just going to name the two ions in it. Sodium bromide. Next, another ionic. Again, no transition metals, so I just name the two ions. Sodium iodide. Another ionic, another one with no transitions. So I'll just look. The two ions are calcium and phosphate. We keep that ending exactly the same. And the last section, we have barium oxide, which is ionic, a metal and a nonmetal. Ba plus 2, O minus 2. So when we cross that over, we're left with just BaO. Trinitrogen heptoxide is covalent. Trinitrogen means we have N3. Heptoxide tells us O7. Copper 2 sulfide is ionic. Copper 2 is Cu with a plus 2 charge. Sulfide, S with a minus 2 charge. So when I cross those over, they simplify just into CuS. B3Cl7 is going to be covalent compound because it's multiple nonmetals. So I'll use my prefixes and call this triboron heptoxide. I have another covalent compound below that with multiple nonmetals. This will be called sulfur dioxide. Remember, no mono if it's the first thing. Lastly, I have an ionic with a transition metal, so let's figure out its charge. CO3 has a minus 2 charge, minus 2 charge. And there's one of them, so that means there's an overall minus 2 charge here. That means I need a plus 2 charge here. Since I have 2 coppers making up that plus 2 charge, each copper is just plus 1, which means when I name this, it is called copper 1 carbonate, indicating the charge of a single copper in parentheses. And my final section, I'm asked to write both the formula, name, and whether it's ionic or covalent in the boxes for each different element combination. So if potassium and oxygen got together, they'd form an ionic bond. Potassium is K plus 1, oxygen is O minus 2. So when we crossed them over, we'd get K2O as their formula, and that would be called potassium oxide. Very simply because there's no transition metal. Next, we have another ionic because we have a metal and a nonmetal. Iron 3 is going to be Fe with a plus 3 charge. Iodate is IO3 with a minus 1 charge. So when I cross those over, I get FeIO3 3. And this would just be called iron 3 iodate, making sure I indicate the charge of my iron because it's a transition metal. Next, I have ammonium and sulfate, again ionic because it involves ions. Ammonium is NH4 plus 1. Sulfate is SO4 minus 2. So when I cross those over, I get that I have 2 NH4s and 1 SO4. When I go to name it, I'll simply name its ions and call it ammonium sulfate. Next, I have a covalent compound. 3 nitrogen and 2 sulfur would form N3S2, and this would be called trinitrogen disulfide. Remembering those prefixes and to change the ending. And lastly, I have sulfur and bromine, another covalent compound. 2 sulfur, 1 bromine would be S2Br. Therefore, my formula is disulfur monobromide. I do have to include that mono if it's the second one. So disulfur monobromide gets me there. Hopefully this helps get you some pattern recognition on naming and formula writing for ionic and covalent compounds. Thanks.